Alright, so now we're talking about 7e. Require and apply relationship, work done equals to force times distance moved in the direction of the force to new situations. This is super important that you understand the distance is the distance moved in the direction of the force. It's not just any distance, but the distance that is moved in the direction of the force. Okay, but before we even go there, what is work done? Work done is really a measure of change in energy, right? So whenever there's work done, there is energy change from one form to another. Work done is energy supplied to a system. Alright, so we're going to examine that relationship in a while, but I just want you to understand that work done is a measure of change in energy. Alright, so whenever there's work done, there is a change in energy. Okay, so but first, force times distance moving direction of the force. In this question, 300 Newton force pulls it up along this xy. They show you the direction of the force. Which distance is the distance in the direction of the force? 3, 4, or 5? Very clearly it's 5, right? Because 5 is this distance, which is in the direction of this force. Okay, so work done equals to 300 force times distance moving in the direction of the force, which will give me 1500 joules. Answer is C. Next question, 18. A pendulum consists of a metal sphere attached to a thin thread as shown in the figure. The mass of the sphere is 200 grams. When the sphere is moved from 0 to x, it is raised through a vertical height of 3 cm. G is 10. Right? So you have H, you have G, you have M. What is the work done used to raise the sphere? Okay, so remember I said work done is a measure of the change in energy, right? So in order to raise the sphere, the work done is the change in energy as it went from here to here. Okay, what's the change in energy as it went from here to here? Assuming that here is at rest, here is also at rest. The main change in energy is the change in GPE. Okay, so so the work done is change in GPE. Okay, this is one way to think about it. So work done equals to change in GPE. So of course it's just MGH, which is 200. Okay, so you need to use SI units, so it's not 200 but 0.200 kg times 10 times the height is 3 cm, but you need to use SI units, and then you should get 0.060 joules. Okay, another way to think about it is that what is the force in raising the sphere? Right, of course, yes, the force the force that you had to overcome was its weight. I know that the force might have acted in this direction, but you don't know this distance. What you do know, though, you don't know how much force you have to use for that. But in order to raise it from here to here, the thing you had to overcome was its weight. So if you talk about its weight, its weight would be mg, and then you have to raise it up this height. So force times distance in the direction of the force, which is opposite to its weight, is 0.03. So again, you see actually it's still mgh, so you will get the same answer. But I think this question more clearly highlights this idea that work done is a measure of change in energy. So the work done to raise is the amount of energy changed during this from O to X. Okay, so it's change in GPE. Next, the maximum speed of the sphere after it has been released, assuming air resistance is negligible. So assuming air resistance is negligible, that means that all the gravitational potential energy at X will be converted to KE at O at the lowest point. Okay, which means KE at KE at O will be equals to the GPE at X. Does that make sense? Because all of the energy here is going to be converted to KE. So this is the maximum KE, right? So KE at O is going to be maximum KE. So this equals to 0.060 joules. Alright, so with this, how do I calculate V? Well, I know that KE at O equals to half mv squared equals to 0.060 joules. Then I want to find V, it's actually just math here, right? So times 2, 0.120 mv square, divide by m, which is 0.2, so that would give me, I think, 0.6, and then V will be square root 0.6, which is 0.775 meters per second 3SF. Okay, so it's really common when they ask you to find the maximum speed, to find the maximum KE and then find the speed. Okay, so the maximum KE is always at the lowest point, and then from there you find the speed accordingly. Question 19, an archer fires an arrow vertically upward into the air as shown in the figure. The string of the bow is pulled back a distance of 60 cm using an average force of 125. Okay, so it's going to move back 60 cm. This arrow has a mass of this, so what do you have here? You have your distance, you have your force, you have your mass. Okay, the energy transferred to the arrow when it is released is 75% of the energy stored in the bow. Okay, so firstly, calculate the work done in pulling back the string of the bow. So work done is simply force times distance moved in the direction of the force. The force is 125, and then the distance moved in the direction of the force is 60 cm because the bow moves back 60 cm, and it's the direction of the force. So convert that to SI units. So it's 0.60. This will give you 75 joules. Okay, so it's 75 joules. Next, the speed with which the arrow leaves the bow. Okay, so you know that 75% of the energy transferred to the arrow when the string is released is 75% of the energy stored in the bow. When the question is how much energy is stored in the bow, right? So actually remember, work done is energy transfer, right? It measures the amount of energy transfer, energy conversion, right? So the work done in pulling back the string of the bow, this work done, actually what did it measure? It measured the amount of energy converted to elastic potential energy in the bow. Okay, so the work done required to pull it back was the amount of energy that was stored in the bow. So now that we know that the energy stored in bow, so energy stored in bow equals to 75 joules, because that's what the work done is, right? But the amount of energy stored in the bow that is transferred to the arrow is only 75%. So energy transferred to arrow equals to 75 times 75 over 100 to get 75%, right? So that will give you 56.25 joules. Alright, so again, I mean, this is a typical question, right? It asks you to find the speed when in arrow. So first you find the KE, and then from there you sub in the formula to find the speed. So of course we're not done yet. We've only found the KE so far. So actually this is KE transferred to arrow, or energy transferred to arrow in the form of KE. Okay, whatever. So so we know that half mv square equals to 56.25. So you just do the math and you'll find that V, same as the previous question, then you'll find that V is simply 25 meters per second. Okay? And now, the maximum height reached by the arrow. So you know that this is the starting velocity. It's going to leave at 25 meters per second. In fact, you know exactly how much energy it has. It has this amount of energy. So at its maximum height, how do you know what's the maximum height? It's when all its KE is converted to gravitational potential energy, right? And so its maximum height, its V equals to 0 because all of the KE is converted to gravitational potential energy. It's at its highest point, it has no KE. Okay, so at maximum height, you know that your GPE will be equals to 56.25 because it's all of the energy has been converted to GPE. okay, and there's nothing in KE. So your GPE is mgh equals to 56.25. So your H max equals to 56.25. Let's just write H now, okay? Don't complicate things. 31. So M is 0.18. You got it from here. M is 0.18, and then G is 10. So just do the math, sub it in. You have the answers lah. So I don't want to go through the working too thoroughly. The main thing is that you understand the 3SF, so 31.3. Okay, the main thing is to understand the thinking behind it. Maximum height means no KE, all change to GPE. Okay, cool.